All right, and we're live. Good evening, guys and gals. Let's wait for folks to chime in. Today is Monday, January 12th, 2026. This is Dr. Drew coming at you with another live stream. Let's wait for a few minutes before folks chime in to the chat. Guys, we're live currently on YouTube and live on TikTok. So now we're live on YouTube as well so that you can rewatch the entire stream for reference and over the years accumulate a stack of content. Ayo, welcome in. GM, welcome in. First on TikTok. Let's see if we get any folks on YouTube. But I think not because we are just starting off. Best name, welcome in. All right, guys and gals, let's pull up the poll for today. Hopefully, if I don't close this, should be good. All right. So let's get 40 minutes on the clock. What should we focus on today? We're gonna start off with organic chemistry. Guys, anyone that's just joining into the chat, welcome into the chat. My name is Dr. Drew. I do have a PhD in chemical engineering, and the way this works, if you're new here, comment the word new so that we know that you're new. And guys, we're gonna go ahead and get this poll. 40 minutes on the clock. There we go. And 40 minutes active now. Jago, welcome in. Guys, vote on the top left hand side of your screen. There's a button that says text poll. And we're going to start off today with organic chemistry, but let me know what classes you're taking by commenting down below and vote on the next topic. Is it going to be A, general chem, B, organic chem, C, physics, D, calculus? King Larry, welcome in. Sup? All right, guys, and pretty much going to jump right into it today. I think we're going to start with organic chem. Pretty much just do a little bit of alcohol reactions to start off with. But feel free to comment down your questions down below. And guys, as usual, if you haven't already heard, we have the Discord link in bio. That's totally free. All right, guys, so let me just pull up this question here and then we'll get started. If you're going to look at my thing, when you think you will get to it? Oh, you're from the Discord. You're from the Discord, right? Liar, welcome in. How about in approximately 1 hour? Are you going to be able to make it in 1 hour while I'll do Q&A? What time is it for you? Right now it's 5:04. So how about 6:04? So basically in about an hour. Does that work for you? Because I'm going to start off with like some general questions. If people have questions, if no one has questions, then maybe we'll do it sooner in like 30 minutes. Okay, so probably approximately like 9:04. But if there's no one here, it seems like a little quiet today because we're just starting off the live. So I'm going to start off with organic chem. Why don't you check back in 30 minutes, King Midas, and then check back in 30 minutes, and then if not, come back in an hour. All right, so the first reaction I'm going to start off with is going to be substitution of alcohols. Today's topic, we're going to focus on alcohols. And alcohols can be prepared via substitution. And so this is going to be our organic chemistry chapter here, our organic chemistry section to start off things today. So I'd like to start off with substitution reactions because they are going to be our backside attack to create. If you recall, you can check out my TikToks or short form vids, as well as my YouTube video where I talk about this as well on my channel. So this is going to be when we convert an alkyl halide, which is of the form R bonded to X, into an alcohol, which is of the form R bonded to OH. Okay. Ariani, welcome in. Thank you for the love. And so this is going to be our, for instance, this is going to be a primary alkyl halide reaction. Is going to be SN2. SN2. Guys, we're currently going over organic chemistry, but you're free to ask any questions you have for math, gen chem, ochem, physics. And then our backside attack is going to basically create an OH over here. How? By engaging in, like I said, backside attack. Then kick off that leaving group to create our alcohol. So that's going to be a primary alcohol. And then next we're going to have tertiary. It's going to be SN1. So this mechanism is slightly longer. So we have tertiary, we're going to have SN1. And this is going to be with water because this is not a strong nucleophile. So first we have to kick off the leaving group, which is going to generate our tertiary carbocation. And then therefore we're going to create our product. Actually, before we do that, we need to first attack. Okay, so now water is ready to attack here. Again, this is a SN1 reaction. Okay, so if you've taken organic chemistry 1, this should be a little bit of review for you, but if you haven't seen this before, please comment your questions down below. And this is going to be H plus. Okay, and then the final step is to deprotonate that guy one final time so that we generate our alcohol as our product. Okay, chat, so anyone that's just chiming in, we are going over organic chemistry currently, but make sure you vote in the poll up on the top left-hand side of your screen, which tells you what do you want to work on today. It's going to be Gen Chem, OChem, Math, Physics. Okay, and also we have the side product HCl. But today, I want to talk about a couple other reactions. Okay, a couple other mechanisms to prepare alcohols. So we also have the acid catalyzed hydration, oxymercuration, demercuration. All right, and then one more is going to be hydroboration, oxidation. All right, but let's see here. So this is going to be where it's really important to identify whether a compound has been oxidized or reduced. So this goes back to general chemistry, right? So in general chemistry, we're going to have oxidation reactions. So let's go ahead and define some of those. Let's go ahead and define some of those. So let's go ahead and start by defining the oxidation state. So oxidation state all right. So oxidation state, also known as oxidation number. Okay, that's going to be once again our bookkeeping for our electrons. It's going to be how we identify whether something is being oxidized or reduced, is gaining electrons or is losing electrons. Okay, so we're going to calculate the formal charge of our elements. No, right now we're doing organic chemistry. And then we're going to determine, we're going to treat all bonds to that atom as if it were purely covalent and then break those bonds. And so to calculate oxidation states, we will take basically a different approach. So let's go ahead and do an example. Let's suppose that we have C bonded to OH, bonded to H over here. All right, and if we treat everything as covalent, we're going to break these bonds homolytically. So that means that we're going to treat these as covalent bonds. It's going to be like this. We're going to generate carbon here, 1, 2, 3, 4. And H will have 1, 2, 3 H's just like that. And then an OH over here as well. All right, so then therefore carbon appears to have 4 electrons, okay? However, do keep in mind if we break them heterolytically, meaning heterolytically, okay? Chat, guys, we have 4 folks in the chat. Anyone that's just joining in, guys, we have a poll active. Vote on the top left-hand side of your screen. Do you want to work on Gen Chem, OChem, Math, or Physics? Let me just check the poll real quick. Let me just check the poll real quick. How are we doing? Guys, tap that button so I can see what we should work on. Okay, we got votes for C. So we got to vote for C. Make sure you tap that button so we got to vote for Physics. So the person that voted for Physics, what topic would you like to go over? Redox is the most confusing topic. Dina, you said redox is confusing? What, are you taking Gen Chem right now? Are you in high school? Please let me know and then I'll be happy to go over it. We're kind of going over redox right now, actually. All right. And then, so now we're going to assume that our OH is basically going to be a minus charge, just like that. So this is going to be assuming that this is covalent or homolytic breaking, okay, or ionic. And guys, anyone that's new here, my name is Dr. Drew. Once again, I do have a PhD in chemical engineering, and I go live every single week to answer your Gen Chem, OChem math questions. So you're free to comment anything down below. Has everyone started the semester already? Has everyone gone back to school, or are you guys still on winter break? So a carbon atom with 4 bonds will always have no formal charge, but its oxidation state can range anywhere from -4 to +4. Okay, I was in Gen Chem 1 freshman college, but I'm taking Gen Chem 2, so I hope it doesn't come back again. Ooh, Dina, I have some bad news for you, my friend. Hopefully I'm saying your name correctly. Is it Dina or Dinah? I have some bad news because you probably will see oxidation numbers once again. So if you'd like to go over that, I'll be happy to go over that. So we can switch gears here to Gen Chem, OChem. Okay, General Chem, Dina. Okay, thank you. General Chem. Okay, I'm going to start with Zay, because Zay said General Chem integrated rate laws. Guys, we're going to switch gears here to integrated rate laws. All right, guys, we're going to switch gears here. So that was like a quick little introduction to alcohols and organic chemistry. Now we're going to switch gears to general chem, and we're going to talk about rate laws. All right, chat. So this is in the chemical kinetics chat. So guys and gals, do me a big favor. Anyone that's just joining in, if you think that rate laws is a good topic to go over next, and you'd like to lock in for this, go ahead and do me a favor and drop a thumbs up down below. Okay, if you're taking general chem or AP chem right now and you think that rate laws are a good topic to go over next, do me a big favor and drop a thumbs up down below or a lock emoji. Okay, and then that way I can know if everyone agrees with this. And if you think this is not a good topic, then make sure you vote on the top left-hand side of your screen. Thank you, Zay. Got that in. Appreciate your interaction. And guys, once again, I go live every single week, Monday through Thursday at 5 o'clock PST. That's 8 o'clock EST, to answer free STEM questions for free, basically free tutoring. So this is in the kinetics chapter. So kinetics is basically how fast. Okay, this is basically kinetics. And this is basically asking how fast. So have you guys started this chapter already, or is it your first time seeing this? So let me just do a quick overview, because we're going to have our kinetics. For instance, in beginning of Gen Chem, you're going to just see A goes to B, right? And then you do stoichiometry. Up to this point, we did not care how fast. Okay, with stoichiometry, we don't care how fast, we only want how much. Okay, so let me write this down. Because stoichiometry is what? Grams to moles, right? So I'm just going to put stoic is how much, and kinetics is how fast. So this is the kinetics chapter. Is this making sense so far? So I want you to understand that's the question you're asking here. So we're going to basically define the change in concentration of reactant A over time. And if you haven't seen this triangle thingy stands for delta. I don't want you to worry about the notation. That's just the notation. The triangle thingy just means delta, right? And delta just means changing. So I just want you to realize that this is basically saying how fast it's changing, right? Has everyone seen this in Gen Chem yet or not yet? Am I going too fast or too slow? So the way we calculate this is basically we're going to calculate the concentration of A, okay, at the final position minus the concentration of A at the initial position with respect to time, T final minus T initial. So you're going to learn more about this in math class. This is more like a math concept. But this is like a really important introduction, because we're going to see how fast something is changing over time. Okay, for example, like a soda can. Imagine you open a soda can, and how long is it going to take before it gets, totally just all the bubbles go away. Jason, can you integrate over a Banach surface in R7 modeling a sphere with 4D tensors? I cannot. That's a great question, though. So the question is, how do we do integrated rate laws? So integrated rate laws means we're going to have to basically do a little bit of calculus here and say that a first order reaction is given by this expression. Okay? So I don't want you to memorize. I want you to basically be like, all right, this is basically A goes to B, and we're assuming it's first order. So just kind of be like, all right, A goes to B. So this is first order. So I'm going to say this is negative KCA. Okay? So that's first order. First order just means that A goes to B. Okay? Nomenclature reaction kinetics. Non-elementary reaction. All right? Substance, I can definitely do that. I am not an endorser for journals, unfortunately. Okay, so this is going to be our first order reaction, negative KCA, right? And so the question is, how do we integrate this? So there's going to be a little bit of calculus. So if you're taking a general chemistry class, you do not need to show the calculus. But a lot of times people want me to show the calculus. So I'm going to show some math here. And the way we're going to do this is we're going to move both sides and integrate. Okay, just like that. Okay, so if you're in a chemistry class, you do not need to know this. But if you're in a calculus class, I want you to know that calculus does come up in chemistry sometimes. Okay, but we do need to pull out our KCA in this integral. And we're going to have dCA as negative K dt. So anyone that's taking calculus, how do we integrate this expression? How do we integrate 1 over KCA dCA equals negative K dt? So this is basically integrating this expression, right? So the solution, so does anyone know the solution to this is going to be natural log, right? CA by C naught. Okay, so the solution here is going to be ln of CA equals CA naught times K negative T. Okay, or you're going to see that at this form, twin. You're going to see it in this form. It's going to basically say CA equals CA naught times e to the negative KT. So this is only for a first order reaction. What do I mean by first order? Remember, first order means it's going to be from A goes to B. Okay? Is this making sense so far? Is this making sense? So the person that asked about integrated rate laws, are you so far so good? Drop a thumbs up if you're so far so good. Drop a thumbs down or a crying emoji if I lost you. So what if I said I have a theoretical on a bridge for QM and GR to be a non-conflicting? Okay, thank you, Dina. Thank you for the interaction. I'm sorry, Birdman, I do not. And CA plus C. 1K for face reveal. So you asked about the constant of integration. This is going to be basically from, I forgot to put my bounds of integration. This is going to be from CA naught to C and T naught to T. So we're not going to have bounds of integration. Boardman, I don't understand your question. Can you drop that one more time? All right, so that's going to be a first order reaction. And so, yeah, that's basically the bottom line for kinetics. So let me just give you guys a table for you to basically memorize. This is the most important thing, okay? So let me just look up a table for reaction kinetics. So the first things first, you're going to put the order right over here. You only need to memorize 3 of them. So that was first order. So all you need to know, memorize is 0th order. All you need to do is memorize 0th order, first order, and second order. You don't need to worry about any other orders. Okay? And then you're going to say the reaction. You're going to say the reaction. Let me see if I can find one for 0th. Let's say reaction goes over here. Okay? And so I'm blanking out on 0 right now, but I know that first is going to be A goes to B, and second is typically going to be A plus B goes to C. I'm blanking out on this one, guys, so maybe someone can help me out for the 0th order reaction. All right, and then we're going to say the integrated rate law. So we've already derived the one for first order. So the integrated rate law is going to be, let's say the rate expression is going to be rate equals negative KCA, and then rate is equal to K times concentration of A times concentration of B. And then we're going to say the integrated rate law. So the integrated rate law is kind of like the formula. So the integrated rate law is going to be basically, for the 0th law is going to be just K. Rate equals K. And the negative means that it's going away. So does everyone understand why it's negative? So these are all negative because it's all decreasing over time. So let's just highlight that. I'm sorry, I do not understand topology, my friend. It sounds very fascinating indeed, but I have not studied topology. Okay, and so the integrated rate expression is going to be your formula here, chat. So there's going to be a table that your professor is going to give you. Okay, you basically have to memorize the table. So this one is going to be C naught e to the negative kt. Okay, and then for second order, I believe it's going to be 1 over, hold on. What is it for second order? I believe it's going to be 1 over A, 1 over the concentration of A equals 1 over the concentration of Ca naught. Remember, Ca naught is the initial concentration. We're going to talk about this. There's a graphical representation. There's a graphical representation, so we're going to go over all of these. Guys, we got 10 folks in the chat. Julie, welcome in. Guys, we got the poll up on the top left-hand side of your screen. Feel free to answer the poll to let me know what topics you guys want to work on. Okay, I think this is going to be, I'm trying to figure out if this is positive or negative. This is going to be a negative minus. One over, hold on a sec, chat. I'm trying to get the second order. Yeah, this is going to be equal to, I believe this is KT over here. And then 0th order is just going to be A, concentration of A equals concentration of A minus KT here as well. All right, so pretty much gonna have all of these reactions here. Now, I think there's something, I'm not 100% sure about this sign and this sign. I think these should all be negative here. Okay, so I'm gonna put that in red. So I can double check that right now. What if we were given a table of concentrations and they say determine which order it is? How do you do that? Okay, that's a really great question. So if they give you a table of concentrations and they ask you to determine which order it is, here's how we do that. So Zay, that's a really great question. By any chance, is this a homework problem or is this in your textbook? Just curious what's the source of this so I can see directly what that would be like. Is there any chance you can either DM me or drop it into Discord, shoot me a DM on Instagram? That way I can see what it is. But let me just start to make up some numbers here. And let's suppose it's something like this. A plus B goes to C. If you shoot me a DM with the actual problem, I can take a look directly. Okay, because typically they're going to tell you something like this. They're going to give you some experiment number. 1, 2, 3, 4. And they're going to tell you the initial concentration. They're going to say Ca01, Ca02, Ca03, Ca04. Same for CB, CB2, CB3, CB4. And then they do the experiment. Yeah, if you can DM me, please let me know. You can DM me on IG or TikTok here. So typically they do an experiment and they give you all these values, right? So then they're gonna say CC1, CC2, CC3, CC4, okay? So if you give me the actual numbers, then let's take a look here. This is gonna be our very first request for today. And guys and gals, welcome into the chat. My name is Dr. Drew. We got 8 folks in the chat. Let's check the poll. If you haven't already, go ahead and top that top left-hand side of your screen to vote for what topic you want to go over today. Let's see how we're doing. Guys and gals, my name is Dr. Drew. Anyone that's new here, do me a favor and comment the word new. If you've never been to a live stream before, comment the word new so that we know that you're new. And if you have been here before, comment that lock emoji because you know we're locked in. All right, we got 1 vote for Gen Chem and 1 vote for physics. Let's see if we get some other votes coming in. And guys, last but not least, you can DM me some questions right here on TikTok or Instagram. I go live every single week, Monday through Thursday, to answer your STEM questions. So whether in high school or college, I got you. And then Zay, I'm going to check my DMs right now to see if I got those sent in. Current topic is Gen Chem, but you can vote for a different topic by tapping that button on the left. Rosie, welcome in. And guys, let me just see what kind of problems we have here. All right, and so if Zay's sending me that right now, then I'm going to describe basically what it's going to look like typically. So typically they're going to give you these different concentrations, right, chat? So let's suppose that they give you these different concentrations. And then what we're going to identify is to basically guess. So for instance, we're going to see that it's going to jump from a different number of concentration, a different level of concentration. Okay, so I'm going to make up some numbers as an example. Maybe this one is controlling, this one might be 1, and this one might be 1. And then we're going to see that if this is 1, then this might also be 1. Okay? But let's suppose that CB changes from 1 to 2, and we'll see in the products here, CC might be also, I don't know, 2. Okay? So namely, what we have to see is carefully identify, all right, did reaction 1, did reactant A or B stay the same? So reactant here, B, in this case, doubled. Okay, so in this case, we're going to see that reactant B doubled. Okay, and then we also see that reactant C also doubled. Okay, so Zay, let me know if you do get that sent in. So if I don't see that, but otherwise, if I don't see that, I might move on for now. And then guys and gals, let me know if there's any other topics you want to go over. So that person, Dina, is Dina still here? Because we can definitely go over, redox next. All right, Zach, DS Alder. Zach, we're going to go back to OChem. We got 1 vote for each, folks. We got 1 vote for Gen Chem, OChem, Math, Physics. And so Zach was the next person, is going to basically ask about DS Alder. So let me put that up on the top screen. So we're going to switch gears here. Now it's back to organic chem. Okay. All right. So next topic, chat, is going to be DS Alder. So DS Alder reaction is going to be with our alkenes. So question for you, Zach. What do you know about alkenes? What is the main constituent for alkenes going to be? And let me just pull this reference up real quick as we go over that together. Okay, so what do you know about alkenes, chat, or Zach? This is going to be our pericyclic reactions, conjugated dienes, DS Alder. All right, there we go. There we go. Now I'm seeing some responses. There we go. C double bond, exactly, right? So DS Alder reaction is going to be for 2 enes, 2 alkene reactions. And remember, an ene is a double bond reaction here. So one of them, for example, is going to be 1,4-butadiene. It's going to look like this, right? So it's a diene because we have, let's count the carbons. We have 1, 2, 3, 4. All right. And I'm going to highlight the double bonds because that's what I want you to realize. Okay? And we're going to pair this with another double bond that looks like that. Okay? So our double bond, there we go. We got 2 votes for OChem. Guys, it's not too late to vote. Tap that button on the top left-hand side of your screen. So now our other double bond here is going to pair up here. And I'm going to erase this, bring this together just like that. And now we see almost a hexagon shape. So I'm going to highlight, I'm going to make a dash here like a hexagon, just like that. And just like that. So that's going to be our 1, 2, 3, 4, 5, 6 cyclic reaction. So here's what I want you to draw, chat. If you're taking OChem right now, follow along and draw this out. We're going to do a little do-si-do merry-go-round. All right, this double bond is going to create this bond right here. This double bond is going to create this bond over here. And then this double bond, okay, is going to create this double bond over here. So at the end of the day, guess what? Now we formed a new compound. It's going to be a double bond just like that. And it's going to be just like that. All right. So, oops, I didn't put anything there yet. Okay. So I like to call this the merry-go-round reaction. Diels-Alder, I like to call it the merry-go-round because we basically go in a little cycle. So a Diels-Alder is a ring closing reaction. And remember, this is only for alkene reactions. Okay. We can also do retroaldol, but we're going to focus on just doing the dienes and identifying the diene and dienophile. All right. So let's go ahead and do an example. Okay. And so we're basically going to have this compound right over here. Like that. Okay, and then this kind of funky looking compound with the nitrile. Triple N, just like that. All right, chat. So I wish that there was a share photos feature in TikTok Live, but there is none. So we're going to have to just talk it out. So go ahead and try out this problem here and draw it out on your own notes or take a screenshot, and then you can either drop it into Discord or up on my comments on my TikTok. But go ahead and take a screenshot. See if you can draw out this reactant. What's going to be the solution here? Okay, so we're going to start off by taking our diene, and let's label this guy as the diene. And then therefore this is going to be the dienophile. Dienophile. So that's the thing that's attracted to the diene. But what I'm going to do is I'm going to make a copy of the diene and a copy of the dienophile, but this time what I'm going to do is make the dienophile kind of close, kind of similar, just like this. Okay, and I kind of erased the triple bond, but just note that this is still a triple bond, just so I can make it just like that, right? Is this making sense, everybody? So now what do you notice about the nitrile groups? It's basically going to be a trans. Okay, so if this is trans, that's going to be a good help here. What exactly is cyclization? Just rearrangement of bonds on a ring. Cyclization is turning something that is not a ring into a closed ring. A ring is anything that is closed. So this is a ring. Okay, so this is a process of cyclization because this is this is open, this is not closed, and then this is closed. It's a ring. Okay. All right. Quagmire says you need heat in the arrow. According to my book, it does not mention that in this particular context. Cameron, thank you for the follow. Keys, thank you for the follow. So chat, let's see if we can rearrange that one more time. So I'm going to go ahead and add the heat to indicate that is in heat here. And so once again, we're going to repeat that process. I'm going to basically create a sort of link here. We see that this is going to be our closed ring right over here and right over here. So this double bond is going to move over here, this one like that, and then this one like that, just like that. All right, perfect. So now therefore the final product is going to be, okay, it's typically going to be a 6-membered ring just like that. Okay, the ene moved over here now, but now we're going to have our CN bond over here. But notice that we are going to have some stereochemistry. So I'm going to arbitrarily make this one wedged. Okay, I'm going to make this one wedged, and then I'm going to make this one dashed. Okay, why? Because this was trans. Okay, this was trans. So this one was wedged, and then this one was dashed here. Okay. Hey Zay, you said you sent it on IG. Let me check my Instagram. Let's check IG real quick. All right, so chat, let me know if there's any questions here. This is basically Diels-Alder. And then, guys, let me know if you have any follow-up questions about how this functions here. Now, Diels-Alder is going to be used to, again, create our cycler rings. We can also do retro Diels-Alder, meaning we're going to start from a ring and then go backwards. Let me know where you guys want to go from here. No problem, Zay. I'm going to see what I got here. I got it here. Hey, Zay, I'm going to respond to this, so now you can shoot me that pic now. All right. So this is going to be one. We're also going to have the enantiomers here. Okay, so this is the products plus enantiomers. Let's do another example. So sometimes they can be a little bit funky, just like this. Chat, let me know. Are you currently taking organic chemistry 2? Is this what you're already going over? So our other one is going to be our dienophile, just like that. All right, perfect. So in the meantime, go ahead and let me know what you think this is going to be. What product do you think this is going to create here? Yes, also up on the website, chat. I'm not going to lie, I haven't checked the problems up on the website. I'm going to bring that up. Thanks for the reminder, Jackson. So guys, remember, you can submit problems either right here on TikTok, in the Discord, on my IG DMs, or up on my website, engineeringminds.co. All right, thank you, Zay. I'm gonna take a look at that right now. So guys, we're gonna do one more OChem problem, and then I'm gonna go back to Gen Chem. Just pretty much just going first come, first serve for today. All right, and so what do we see here? So which one of these is the diene, and which one of these is the dienophile, chat? So those of you that are following along and viewing these solutions, which of these is the diene and which is the dienophile here? Okay, so I see on the left-hand side we have the diene because we have our two enes. So that's going to be our double bond and our double bond. And then I see my dienophile. Okay, so what I'm going to do is I'm going to bring them closer together. Remember, organic chemistry is basically literally match made in heaven, chat, right? Whenever you're doing OChem reactions, you're just playing matchmaker. So we're bringing them close together. And then I'm going to start to draw my little dash just like that. Dash just like that. All right, bring that up just like that. And just like that. And boom. Now we created our pairs. Now, the one thing that I do want you to be careful about, though, is that notice that this is a single bond attached to what? An ester group. Okay? So before we completely replicate that, I do want you to realize that this is attached to an ester. So let's see if we have any stereochem here. I'm going to move this over to the side. We're going to have a cycle just like this. Cyclohexane with one double bond in here. All right, but what am I missing here, chat? What's missing on my final product? What's missing on my final product that I have to add? So what am I going to attach here in the final product? I basically have to attach, so one of these is going to be our double bond OMe. And this one's going to be a double bond OMe, just like that. Okay. So I think we are good here. Let me just double check if we're missing anything. Let me know if there's any questions about that one so far. One sec, guys. I'm just going to double check this answer real quick and see if we're on the same page. And then Zay, you're going to be up next. So I'm going to check my DMs right now. Guys, any more last minute questions about DS Alder before we switch gears here back to Gen Chem? Any more questions here? Any more last minute questions about DS Alder? We're going to switch back to Gen Chem in just a moment. I just want to double check this problem real quick. 1714. All right, and it looks like we should be solid. Looks like we should be solid. Okay. $17. Sorry, chat. 1 second. I just want to double check this one more time. So yeah, it's basically our DS Alder reaction. 17, 14, 18. Here we go. Oh, so we are indeed gonna have some stereochemistry here. So I'm glad I checked this. This one's gonna be wedged. Okay. And then this one also got to be wedged. Okay. If you forget the wedge, you will not get credit. So the reason this is wedged is because this is coming out at you. And so therefore this is going to be a meso compound. Okay. So it's going to be a meso compound. All right, Zay, let me know if you're still here. You are up next, my friend. We're going to basically take a look at your Gen Chem question. And that was a quick little overview of DS Alder. Jimmy, thank you for the love. General chemistry. All right, so the next topic we're going to do, let's see, is this still rate law? There we go. So this is rate law here. So I'm going to send myself this pic, and we're going to take a look at it together. Vikali needs help with air pollution? Yeah, I can probably help out with that. That's more engineering, right? What do you have? Do you have homework? Yeah, I tutor engineering as well. Squidward. Okay. So, Zay, are you still here? Because you are up next, twin. So this is going to be our general chemistry. Consider the data below. Let's go ahead and pull this up on the large screen so everyone can see. And guys, I am live here on TikTok as well as YouTube, so you can rewatch the entire thing in case you miss any part of that. All right, thank you, Zay. Yeah, Vikali, I got you on tutoring for engineering. Just let me know what you're taking right now. So, again, this is back to Gen Chem, guys. So this is a really good example. It says consider the data below. Can everyone read that? Consider the data below showing the initial rate of reaction. Okay, CH3, COOC2H5, aqueous, in hydroxide, CH3CO2 minus plus water. All right, great. And at different initial concentrations of CH3CO, C2H5, and OH minus. Perfect. So, what is the rate law for this reaction? What is the value of the rate constant K, and what is the overall order of the reaction? This is a really very typical common question. So we're going to break this down. You know what? This is such a great question. I might turn this into a TikTok. All right, Vikali, please message me or check out my website, engineeringminds.co, for details. GH, thank you for the love. Thank you for the follow. Okay, so let's reread this carefully one more time. So here's the reaction. This is the reaction, right? And they're basically asking us, all right, what is the rate law? What is the value of the rate constant? And the overall order. Okay? So guess what? You can guess. You can either say, hey, I'm just going to guess it's first order, second order, third order. Or zeroth order, rather, not third. But instead of guessing, let's go ahead and do this systematically here. Okay? So this is basically an experiment. They didn't put this extra column here, but I want you to realize, by the way, guys, is the music too loud? Let me bring down the music just a tad. This is an experiment. And so with the experiment, we have to identify what is being changed, what is being kept constant. So let's take a look at experiment 1. Zay, what happened in experiment 1? Hey, Florida. So in experiment 1, Zay, can you please describe, look, we have 0.05, right, and 0.05. All right, so that rate order was already calculated. That was given. So by the way, I kind of already know the answer because they gave it away with the units. So if you know the units, then you can already know. So the units are in molars per second, molar per second. Okay? So I already know that this should be first order, I believe. I believe it's going to be first order. I'm going to guess that it's first order. Okay? So this is moles per liter per second, so that's molar per second. And let's see what happens, okay? So when this stayed the same, so notice from experiment 1 to experiment 2, this stayed the same, nothing changed, right? OH concentration stayed the same. But what happened to concentration of reactant A? It doubled. This is times 2. So when OH minus stayed constant, let's call this constant, nothing changed here. No change, right? But reactant 1 doubled. What happened to the reactant rate? It also doubled, right? What is 2.8 divided by 5.5? So what is 5.5 divided by 2.8? I basically want you to put on your chemistry hat, your scientist cap. It also doubled. So that's telling us from experiment 2, I'm going to write this down. Experiment 2 tells us that when reactant A doubled, I'm going to call this concentration of A doubled, then the reactant rate also doubled. So therefore, what does that tell us then? So what does that tell us, chat? If concentration of A doubled and then the rate order also doubled, then that means that therefore the rate is proportional to what? To CA, right? Okay? It's proportional to CA. Yeah, it could potentially be first order. It's first, so therefore it's first order in CA. But now we got to check CB. Okay? So now for experiment 3, and you're right. You're right. So now nothing changed here, no change. Okay, so by the way, guys, I am recording this on YouTube as well. So if you missed this, you want to rewatch it, I'm on YouTube as well. Okay, and then what happened to reactant B? So this was times 1/2. So from 0.05 to 0.025, what happened? We went down by 2. We decreased half, right? And then similarly, also 1/2 for the reactant rate. So I want you to write out, okay, also similarly, when CB halved, then the rate also halved. So that tells us that we're first order in CB. So first order plus first order is second order. So the final answer is going to be second order. Okay? So let me know if that made sense. I know this chapter is like a little bit confusing for folk, especially if your Gen Chem 1 background is kind of not on the strong side, then Gen Chem 2, this kinetics chapter is a little bit funky. Okay, so I want you to really start to think like a scientist for this chapter. Okay, guys, let me know if this is making sense, guys, and drop a thumbs up if this made sense here and you agree with what I'm saying here. Okay, so that's going to be the overall order. Okay, and once again, you can you can rewatch the entire thing up on YouTube later tonight. All right, and what else did it ask? So that was the rate law for the reaction. So therefore, the rate law is going to be concentration of A times concentration of B. Okay, times the reactant rate constant. The reactant rate constant is just a proportionality constant. All right. And then it's going to be second order. Lastly, we have to calculate the value of the rate constant K. I forgot all of this. I haven't seen it since Gen Chem. Ooh, Chris, if you haven't seen this, have you taken kinetics? Because this is literally, you take an entire class on this called kinetics, where literally the entire class is just this chapter. Okay, all we have to do is get the rate constant K. So the way we can get that is, let's put that as, by the way, I'm getting a little bit lazy. I shouldn't write A, B. I should actually write CH3COOCO2. So I'm going to erase that. So don't be lazy like me. You should do that as CH3COO C2H5 times OH minus times our reactant rate K. Our reactant constant K. So our job is to get K. And guess what? We have two of these, right? So all I'm going to take is, for instance, R2 divided by R1. So I'm going to take R2 divided by R1. That is 5.5 times 10 to the minus 4 divided by 2.8 times 10 to the minus 4. Okay, and let's just go ahead and verify. Nope, that's not what we do here. Hold on a sec. That's going to cancel out to 1. So let me just show you what I was about to do and why it's going to be wrong. I was about to calculate this. Because remember, guys, I'm doing this live. I've never seen this before, so I just want to show you what I was about to do. And that's going to effectively cancel out everything. So that should be, that's just going to give us a ratio. So that's just going to be 1. Hey, what's up, math tutor? Kinetics next semester. Kinetics reaction engineering. Yep. That's a fun one. That's a very, very fundamental chemical engineering class. Okay, lots of math in that one. Keep that in mind. So, not that this is wrong. It's just that this is not useful. So I want to get K, guys, and then we're almost done. Thank you for the heart me. Shouts out math tutor, guys. Also another math tutor, TikTok creator. All right, guys, so then I forgot to divide. We can just get rate. Let's just use one reaction here. So all I'm going to do is, rather than do this, I'm going to erase all of that. And I'm going to just solve for K here. I'm just going to plug in the numbers. Okay? So let's suppose I'm going to use reaction 1. And I'm going to say that K is equal to those rates. Okay, I'm going to just plug that in. Let's suppose that's 2.8 times 10 to the minus 4 divided by 0.05 squared. And if you say, hey, why did you choose reaction 1? Why not reaction 2 or 3? Well, it's a constant. So if I chose one or the other, theoretically, it should be the same. As a matter of fact, I encourage you to test it out. It should be all identical, because it's a constant. That's what constant means. It means it doesn't change. How can you use physics IRL to get hydroxide ions? Do you mean hydroxide? He said hydroxide, guys, right? 2.8 times 10 to the minus 4. Thank God the YouTube replay can't see comments, because sometimes y'all are unhinged. So I got 0.112. And then that's going to be in moles per second per mole squared. So that's going to be inverse molar inverse second. That's going to be inverse molar, inverse second. Okay? All right, and then that's going to be our final answer. Zay, was that helpful or was that too fast for you? Was that helpful or was that too fast for you? This is the general. I'm definitely going to turn this into TikTok. That was a great question. Okay? That's a really great question. You know darn well I ain't asking about chem. All right, Big, you got me. Listen, you want the answer? So how can you use physics? Here's how you do it. You get your degree in physics, you get a job, you live a worthy life, and that's how you can get married, have a kids, you can do whatever you want at that point. Can you use chemistry to get some bread? Of course, exactly. That's what I'm saying. Get your degree, get a job, get that bread. Very helpful. Thanks so much, better than my professor. Of course. That's why I'm here. I love teaching because not to flex guys, but I love teaching. Like, that's why I'm here, because it makes it more enjoyable for all of us. Okay, because I get to review. Okay, I'm having fun. Sometimes people are like, bro, get a real job. Bro, I'm having fun here. What do you mean? This is like a hobby for me. All right, guys. So then, pretty much I don't see any requests. So like, let's just check. Okay, I have a Discord request and it's 6 o'clock. So I promised that someone in the Discord that we were gonna do his problem next, guys. Okay, I'm just gonna pull up the Discord question and we're gonna work on it together. And at this point, we're gonna be all lost together because it's an engineering question. So we're all gonna be lost together. So do bear with me. Every time I do engineering live, it's always a struggle. Explain why pure liquids are not included in rate constant. Okay, great question. So what's not included in rate constant? Liquids, solids, pretty much just liquid and solids. You only want aqueous compounds. Okay? You only want aqueous compounds. Popcorn says, bro, we want OChem. Let me see how many OChem we got. We're going to do OChem right now, guys, but I promised someone in the Discord. Discord is a priority, guys. So if you want to join up on the link in bio. Let's just see how many we got in the poll. We got 2 votes for OChem and 2 for GenChem. So technically it's not accurate. Let me just pull this up here. That's because they do not change concentration. It's not because they don't change concentration. It's more of like a how to explain it. It's because they said so. It's a standard reference. So the chemist that invented equilibrium back in the day, this was Gibbs, Johannes Gibbs, who invented thermodynamics. He basically said, hey guys, let's make a reference state and let's use aqueous solutions only for water. If it's not an aqueous solutions, don't include it. And then everyone else said, hey, bet. Everyone else said, hey, bet. You know what? Let's not worry about it, twin. And that's what we've been doing for the past 130 years, so we don't change it. So that's why we only include aqueous, not liquid solid. Hope that made sense. Hope that wasn't a wishy-washy. Because the answer is thermodynamics. And thermodynamics is always wishy-washy. Guys, I'm pulling up this question from the Discord. I'm going to do window capture. And then King, when you're here, let me know when you're here so we'll go over it together. Do I do DAT? What's on the DAT? I do Gen Chem, Math, Physics. I don't do Biology. So if you're taking the DAT, I can do General Chemistry, Physics, Organic Chemistry, and Mathematics. I just can't do Biology. Need help with my first Gen Chem 1 course. Yeah, Chen, you're in the right place. If you need any help, you can join the Discord for absolutely free. Guys, anyone that's taking Gen Chem, can you provide tips? My tip is always the same. It's practice problems. Okay, my tip is always the same. It's always do practice problems. And obviously study ahead of time, read the book. Watch OChem Tutor. OChem Tutor is really, really, really good for Gen Chem, guys. And Khan Academy. No, but if you do istables, it's because a solid or pure liquid doesn't have a change in concentration. Same with why istables will give you different expressions. Same exact thing, right, Muzz? That's the same answer. All right, guys, the next topic today is going to be engineering. So we're going to have to interpret this data together and basically try to read this steam property exercise. King, once you're here, let me know because you are up next now. And then let me pull up one more thing, guys. We're going to read this together. We're going to try to interpret this. Sometimes engineering can be a little bit scary, so if you guys get bored and you want to leave, I understand. If you get bored and you want to leave the live stream, I understand because we're going to be here for a while. Let's just put it that way. It's too small. All right, one sec. Let me put them on both sides. First, let's read this PowerPoint together. First, let's do an overview. Okay. So it says, let's basically read it together. Don't need that. State representation, computer-based steam lookup. Oh, hey, King. Welcome in. Thanks for chiming back in. So, state representation, computer-based steam lookup, work before class 1, submit this exercise to Brightspace, blah, blah, blah. Mass-specific pressure, PSAT, temperature, quality, volume, enthalpy, entropy. Computer-based steam lookup. Hand, table or chart. Excel, certain error stream. LabVIEW, certain error stream. MATLAB, certain error stream. Okay, so here's what I understand, guys. Here's what I understand. We're gonna basically all work on this together. So this table is a steam table, and here's an example. So we basically have to memorize these 5 terms. We have temperature, composition, X is composition, V is volume, H is enthalpy, and S is entropy. Add a Subway Surfers bit. Okay, Eric, I might do that next time. Is someone I need to download one though. I need to download one. Okay. And so on the green side, here's what we know. And then here's what we're trying to calculate. So for example, here, composition. We know composition, volume, enthalpy, and entropy. And then we're trying to calculate T, right? And then similarly here, we know temperature, V, H, S. We're trying to calculate X. All right. So that's what we know. So for example, pressure is known, so use P functions. So like, let's just see if anything changes here. So I'm just going to change this to like, let's say 1,000. Okay, nothing changed. So he gave you the formulas here. Okay, do you see how there's a little, like, what's that symbol called? It's a little like thing. You backspace that. Now the formula is activated. Boom. There we go. So let's change that to 1 again. And then over here, we're going to delete this little line. So now, all right, he gave you the formula. So you don't need to code anything. He already put it for you. Okay. X is quality. Okay. And then delete this one here. And then delete this just like that. All right. So we got 101.59. All right. So the state is organized as row known information is shaded beige. The unknown cells have a function that is px2z, p cell, x cell, where z is the letter of the unknown. Type these as row equals 28. I want to change this. What if I change this to 0.2? Nothing's changing. And why is it crossed off? When you press enter after typing in the cell's formula, the cell will evaluate the function and return the number. When you press enter after typing in the cell's formula, the cell will evaluate the function and return the number. I'm typing in the number, but the cell is not evaluating anything. The cell is not changing. So that's my first gripe, chat. So I'm changing in some numbers, but nothing is changing. For reporting, adjust the number of digits to 3 sig figs. Nothing is changing. Nothing is changing. Notes. A quality of X is less than 0 indicates a compressed liquid or subcooled liquid. A quality of X greater than 1 indicates a superheated vapor. The data used for interpolation is for pressures in the range 0.1 to 3000. The data used for interpolation for enthalpy is in the range 0 to 1580. Current pressure. All right, exercise. Name, Dr. Drew. Complete this worksheet prior to lecture 1. Fill in the cells below, print this single sheet as a PDF, and submit the PDF to Brightspace. Okay, guys, so hand lookup calculation. Literally look up the values either in a Steam table. Okay, King Midas, I'm gonna let you do this one. So you literally, like, do you have a textbook? I can drop it in the Discord if you need one. So literally it's gonna be in a table and you're gonna just literally like put these in, okay? So they gave you the pressure and then the temperature, quality. I don't know what is quality. I thought this was gonna be concentration. So, okay, for a chemical engineer, we say concentration. Okay, we say concentration. Apparently you guys say quality. And this is pound mass per, this is pound molar volume per pound mass. Volume is feet cubed per pound mass, enthalpy, BTU per pound mass, entropy. Oh God. Also, you have American units. And American units are a pain. I have the Steam tables, but none of the values were given or in them. Interpolation, okay. There's a formula for interpolation. It's basically like slope. It's basically like the point slope form. Interpolation is basically algebra. Let me just write this down real quick. So let me hide this. Let me hide this. Let me give you the formula for linear interpolation so that way you're not totally lost there. But just realize that it's basically the same as point slope. Okay? So linear interpolation. Linear interpolation. Okay? So let's say you have a point x1, y1, x2, y2, and you want a point x, y in between. So that means you're interpolating, you're getting the points in between x1 and y1, x2, y2. So the formula is simply going to be y equals y1 plus x minus x1 times y2 minus y1 divided by x2 minus x1. Okay? So you can actually derive this yourself using algebra. So let me just do a quick example. If you have the data that is linear like this, so when you have your close point, this one is x1, y1. I think I have an old video on how to derive it on my channel. Yeah, you can check out the derivation on my channel. And then here's the point for x. This is going to be x comma y. Okay? So basically I want you to get that part. Oh no, TikTok's going to ban me, guys. Guys, if I get kicked out, do me a favor and rejoin. Let's see what happens. But I'm going to proceed for now. So, let me get back your Excel sheet so we can work on this together. It can be interpreted as coordinates, correct? Yes, I can. Hey, philosopher, welcome in. Okay, let me bring this back one more time. Once again, guys, we're going over some engineering right now. Let me hide this and hide that. Okay, so where are we here? Okay, can you guys see that? Oh no, you guys can't see that. Hold on a sec. Let me try to hide this. All right. What happens if I close that? Okay, can you guys see that? There we go. So now we have this data, right? So I'm gonna skip this part. I'm gonna help you out with this part. So use Excel functions to determine the state variables. Okay. Fill according to cell color codes. All right, let's see if we can at least do just one of these together. So let's see pressure. Oh man, this is indeed very confusing. Gotta love engineering. So this is px2t, function names. Function names. Okay, this is indeed very confusing. So let's check the PowerPoint. Did he define the functions? Where are the functions defined? I don't see anything. Enter links to given data in hand calculation table. Enter formulas to complete steam table. Compare and convert. Example points. Steam TS. Example pass. Big boiler. Big Moliere. So part one, hand calculations for the 885 PSA at 955. I have. Okay, I'm gonna write down what you're saying. So part one, for 885 at 995, I have x equals 1.4, v equals 0.921, and h equals 1484.1, and s equals 1.6513. Go to hidden Excel. I know there's a lot of stuff there. Go to hidden. Where is hidden? Data. Did he like define them? Like where would it be? Right click on the bottom tab. Okay. Unhide. Oh, there we go. Okay, so enthalpy grid. Unhide. Use control key shift. Yeah, unhide everything. I want to see everything. Show me all the data. Oh, there's a crap ton of sheets. Wait, this is actually really useful. If we figured out how to use this, this can be used for any engineering. This can be really useful for chemical engineering as well. All right, my computer might explode because I just unhid everything. Let's see what happens.